Hi there. So today we'll be starting on. Hi. So today we're gonna be doing the NeetCode 150 or the NeetCode Roadmap. Oh shoot. Hi. Today we're doing the NeetCode Roadmap, and we're gonna be starting day 1 on contains duplicate. I already have the LeetCode put up here, and so reading the problem description, it says, given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. So we're given the nums here, and we're trying to figure out whether at least any value appears, or if any value appears at least twice in the array. So as we can see here, at least 1 and 1 here appear, so that's why we return true. And here there's no duplicate numbers, no value appears at least twice in the array, so we return false. And lastly here we have 1s, we have 3s, we have a bunch of numbers, and all these appear twice. But our goal here is to just figure out if any value appears at least twice in this array. Okay, so let's suppose we have a list like 2, 1, 3, 4, 1, and let's do 6. So from here, we can see that there is a, we are supposed to return true because a value appears at least twice in the array, but intuitively, you would start, let's say we start here. So you run a loop and you check at index I, and then you have a second pointer at index j, and so at index, for every loop of index I, you run a second counter that checks the next value, and so you basically check the rest of the list. So let's say is index I and index j, are these two values equal? No. So then you move forward, and then are these equal? No, you move forward. Are these equal? You move forward. Are these equal? No, you move forward. And are these equal? You move forward. And then so after we realize that there are no duplicates of the value at index I, then we can increment I to the next index. And so we do the same thing again. So we set j to the next value after I, and then so is 1 and 3 equal here? And so these two are not equal, so we'll increment to this next value, and this one's not equal, and then so we increment here, and this one is equal. So we currently have found our two duplicate values, and so then at this point we would just break and return true. So now we're going to get into why this isn't the most optimal solution. So we have an array here. Let's say the length of the array, we'll call it n, okay? And so if we have a for loop essentially running from I, and in this problem we essentially go over the array, keeping track of every value here. So if this value, if we ran through the whole thing with j, and we know that there is no duplicate, then we basically take this, and then we move it over, and take this, and then we move it over, right? And so essentially we could potentially be moving this I value over, or this I value over like n times here, right? And so each time we move it over, the j value would check, it would check, it would check, it would check, and then after it finishes this iteration, we move I over, and then j, check, check, check. And so because of that, we know that j would be checking n times as well every time that I checks, for every count of I, right? And so from that we can tell that the time complexity of this would be O of n times n, where n here is the loop going over the array one time to just get every individual first value, and then j would essentially be the iteration over each counter of I. And so that would give us the ultimate time complexity of O of n squared. And from this, although the solution may look like it's fine, let's say n is arbitrarily large, like maybe like a billion values, you'd basically be doing 1 billion times, or 1 billion squared values, right? And there's a solution that can cut that down into just O of n, which I'll be getting into right now. So let's suppose we use the example 1, 2, 3, 1. And the way we'll do this is by keeping track of the data that we've seen so far in the array. So by doing that, or the way we can do that is by using a set. And so the algorithm will work like this essentially. So we'll start with a counter here, and essentially at every single iteration, we'll keep track of whether or not we have seen the item in the set. So the set initially will have an empty state. And so at index of 0, we'll basically check, have we seen a 1 in the set? Currently, is there a 1 in the set? And as we can see, there's not a 1. And so what we'll do next is, if we do not see something that matches in the set, we append it into the set, and then we iterate. At this current step, do we see if there's a 2 in the set? We do not. So we add it, and then we iterate. And then same thing for 3, we don't see 3, and then we iterate. And then now that we've gone to index 3, we see that there's not a, we don't see that there's, or we see that there's a 1, sorry. And so what we'll do there is we'll essentially return true, and that's our solution. Okay, let's get into the coding implementation. So like I said, we're going to have a set which keeps track of whether or not we have seen something already once. So we're going to call it seen, and essentially we're going to go over the array for every value in the array, right? And so we need a loop to do that. So for I in nums, this will go over every value in nums, and if I in seen, this basically, if there's already the value I in seen, we can just return true because we know that that value exists already, right? And otherwise, if we haven't seen I in seen, all we do is just add to seen. So we would do seen.add I. And lastly, if we don't see anything, or yeah, if there's no duplicates, right? We've gone over the whole array and we haven't returned true, that's why we returned false, because we know that there is no duplicate. And hopefully when we run this, it should be good. Yep. And as we can see, it's pretty fast, but there is a faster solution. So a set is essentially an array, but you can access it in O of 1 time, and that it contains no duplicates, right? And based on this, we don't need to even iterate over like the whole array. A simpler way is just we keep track of the length of the set compared to the length of the array, the original array. So what I'm trying to say is, let's say we have an array like 1, or let's say nums equals 1, 2, 3, 1. And if we call set on nums, that would give us 1, 2, 3, right? And the ordering is arbitrary. It could be anything in regards to sets. And so as you can see, the length of len of nums, it equals to 4, but the len of set nums equals to 3. And the reason that it kind of truncated to 3 is because a set doesn't keep track of duplicates and it only keeps track of distinctive values. And based on that, we can tell there's distinct values because the len of nums minus the len of set nums is greater than 0. That means that we have duplicate values in our nums array. And so based on this, we can just, okay, so then if we try doing return, we're going to return if the len of nums doesn't equal the len of set nums. And why we do this is because if, let's say there's no duplicate values, right? So this should be 4 and this should be 4 as well, right? So if these equal, or if there are no duplicates, then this would evaluate to 4 doesn't equal to 4, meaning that there are no duplicates, right? And so, of course, that'll return false like the description wants. But if this is 3, then it would return 4 doesn't equal 3, which is true, and ultimately we get the correct output. So this way we'll submit and it should be faster. Oh, I guess I forgot a closing thing. Set nums. Oh my god. And there we go.